This is pre-algebra video 1-9 for lesson 1-9, and I am on page 43 in the pre-algebra book. This should be a quick lesson. It's on interpreting graphs and tables, and it's pretty cool stuff actually, but I will be moving through it quickly, so don't hesitate to pause, to review, to rewatch, whatever you need to do, or to study the lessons in the book. The table below shows how quickly the temperature can increase in a car that's left parked during an afternoon of errands when the outside temperature is 93 degrees Fahrenheit. So let's practice reading a table. And I'm going to show you as much of it as I can in my phone screen, but you should have your book open. The temperature on arrival, well, we're at home, we're already there, so we don't have an arrival temperature. But on departure, it's 140 degrees at 1:05 in the afternoon. We ran to the cleaners. We got there at 1:15 and the temperature was 75 degrees. Upon sitting, the car increases temperature by 20 degrees over the course of 10 minutes. So now it's 95 degrees at 1:25. Okay, I just want to do a disclaimer really quickly. It's probably either 9 o'clock or after 9 o'clock at this point at night that I am doing this video. Forgive me if I make mistakes. I am bound to. It's been a long, busy day, but I'm determined to get this done for y'all. Okay, so now we go to the mall. It's 72 degrees when we get there at 1:45. But look at this. We stay at the mall for 2 hours, and look what happens to the temperature. It jumps an obscene amount, up to 165 degrees. And then you can see, lastly, we go to the market. We've been running the air conditioner in the car. The temperature's now at 80 degrees at 4 o'clock. We stay for 20 minutes, and it jumps 45 degrees, from 80 degrees to 125 degrees. That's pretty amazing. Well, we're going to come back to this and use it later in our lesson, but let's move on to practicing more reading of tables and answering questions based on them. And I'm going to have to kind of move my phone as we go. The table gives the speeds of 3 dogs in miles per hour at given times. Tell which dog corresponds to each situation described below. So we're going to read the table and we're going to read the descriptions and decide which one matches which. Now I know that you can see the answers, but I would like for you to try not to look at them, and let's just focus on reading the material. Example A says, David's dog chews on a toy, then runs to the backyard, then sits and barks, and then runs back to the toy and sits. We need to learn how to evaluate or read the information on a graph and make sense of it. So if David's dog was chewing on a toy, he was probably sitting still. So we're going to say that he was at 0 miles per hour and that he's either dog 2 or dog 3. He then runs to the backyard, but then he sits and barks. So whatever he does, he's going to have speed and then 0 again. So far it's looking like he's going to be dog 2, but let's keep reading. He then runs back to the toy. There he is running back to the toy, and then he sits again. So as you can see, that's dog 2. Let's look at the next one. Try not to look at the answer. Kareem's dog runs with him and then chases a cat until Kareem calls for him to come back. The dog returns to his side and sits. Well, I'm guessing that the dog's fastest speed in this description was when he was chasing the cat, but let's look and see. He was not still to start with, so he really cannot be dog 2 or 3. He has to be dog 1. Now let's see if the data matches the description. He's running with Kareem, still running with Kareem, and then he flies off chasing the cat. Then Kareem calls him back, and if you can imagine, I have a dog and she doesn't always come speedily when called. So he's just taking his precious little time coming back. And then what did it say? He returns to Kareem's side and sits. So there he is back at 0. So this is definitely dog 1. And now let's look at Janelle's dog. Janelle's dog sits on top of a poolside, sitting at 0, slides into the swimming pool and swims to the ladder. This could be sliding into the swimming pool and swimming into the ladder. He gets out of the pool and shakes off, so there he is, not making forward motion, and then he runs around the pool. That was the only dog left on the table, but the data fits, and so we're going to say that dog 3 is Janelle's dog. And now we're going to turn the page and keep practicing. We've got a couple more things to look at. Now we're going to look at charts. We looked at a table in the previous example, but this is example 2 at the top of page 44, and it's looking at graphs or charts. Tell which graph corresponds to each situation described in the previous example. That's going to be hard because I'm going to have to keep, nope, I'm not going to keep flipping back and forth. We're just going to look at what they've written. Actually, that's not going to help. We are going to have to go back and look. So let's go back and look at David's dog. David's dog was letter A. And let's go back and read the description. David's dog chews on a toy, runs to the backyard, sits and barks, then runs back to the toy and sits. So we have still, running, still, running, still. So still, running, still, running, still. Let's go over here and look for a graph that would be that. The only one that I see that's appropriate is graph 2. Here this is his speed, this is the time. This would be 0 at the bottom of the speed y-axis. So we're going to say still, then running, then still, then running, then still. So graph 2 would be the one that illustrates David's dog. Now let's go look at Kareem's dog. That was the one where they started out running. They ran, then they hurried, then he went very fast and chased a cat, then he slowly came back to Kareem, and then he sat. So let's go look at one that would describe that. Which one has kind of an extreme increase? If you look at graph 3, you'll see that. This could describe the data that we just looked at or read. He was running with his master, then whoop, chasing the cat, then slowly coming back when he was called, then sitting still next to his master, Kareem. So, example B would be graph 3. And then Janelle's dog, I can't remember what Janelle's story was. Oh yeah, sitting on the side of the pool, let's see. Sitting on the top of the slide, then sliding into the pool, swimming to the ladder, getting out, and sitting. Let's go back and see if the last graph would fit with that. Yes, sitting on the slide, then some speed sliding, then the same speed roughly swimming to the ladder, then sitting still after he got out of the pool, and then running around the pool. So we have a big increase in speed. So that's how you read those, and it's really kind of cool to interpret material like this. Let's move on to the last one. This is going back to our errands and the heat in the car. The temperature inside a car can get dangerously high. Create a graph that illustrates the temperature inside the car. So on your homework, you would need to create a table. Unless they gave it to you, it would be wonderful if they gave it to you. And actually, I'm glancing at your homework, and I think they may give it to you on all of them, which would be wonderful. And that way, you would only have to create the graph. On a graph, I want you to notice right here that we are going to be measuring temperature up the y-axis and time across the x-axis. And what I want you to see is that you don't always have to count by 1 for every grid. In this case, because we have extremely high temperatures, I say they're extremely high compared to 0 at the origin of the graph. There's no way that we could count by 1s on this graph because our graph would be pages and pages long to get up to our highest temperatures at around 165 and 140. So we can choose what we count by. Any two people's graphs could look different based on the increments that they choose. They chose to count by 50s. I could have chosen to count by 25s or hundreds. And I think that that's all I needed to tell you about that. Sorry, something just broke downstairs. I think my husband got home and knocked off something glass, and now I'm very distracted. So I'm going to run through this really fast so I can go downstairs and help him. So the time they've chosen to do by hours, 1 o'clock, 2 o'clock, 3 o'clock, and 4 o'clock. And then they look at this information and they graph it. At 1 o'clock, the temperature was 140. Look, 1 o'clock, they go close to 150, but they just are at 140. At 1:10, they drop down to 75 degrees, halfway between 50 and 100. And they estimated what time 1:10 would be, early in the 1 o'clock hour. At 1:20, they're at 95 degrees. Again, they're estimating where 1:20 would be, and they're at 95 degrees, so they're estimating where 95 degrees is, very close to 100. And I need to go check on my precious husband, y'all, so I'm going to stop there. I've given you the first 3. You can follow along and see what they've done with the last 4, and that shows you how to do a graph, but you do need to connect your points by using a ruler. Don't freehand that. Connect your points so that your graph makes sense like this, that you have lines that are readable. All right, I'm going to scoot, and I hope that helps.